Hello GameMakers, this is GameMaker Rob, and in today's episode we finally get to move the units around. We have them change facing while moving, the option to change facing after finishing moving, and we also show a little bit of how the attack system might work as well. So let's get started. Okay, so the first thing we are going to do is set up a menu for the battle system. So for that we are going to need a new sprite, and I've called it SPR_battle_menu_button. It's a sprite here. It's 160 by 64 and centered in the middle. And the way it's going to work is we're going to have several options. Most of them are going to have a grey background, a dark grey background. Whatever option is highlighted is going to be like this, just so we can easily tell what's what. Then if we go into the create event of OBJ test, we've got a couple of new things in here. So we have a new enumerator. This is going to cover, well, these four options are going to be for the battle menu. Awaiting action is going to let us know whether we've actually chosen one of these or not. So we're going to have a variable called current action, and it's going to be set to this at the start of every unit's turn, and they're going to pick an option from this menu. When they pick one of these options, current action is going to get set to this, and when the character is done moving, it's going to get an option to choose its facing as well. So that's when current action will equal this. And just so we can draw some text on the buttons, we've got an array like this, and we might as well have an entry for choose facing as well, like this. So that's the three new things inside the create event. And for now, we're just going to draw it. So let's go into the draw GUI. We've got a new region here called draw battle menu. If the current action is awaiting action and the actor is taking their turn, then we want to display the menu. So we want to draw it from we want to draw our text from the center and middle because our buttons are centered in the middle. Set color to white for the text. We're going to use the conversation font for this. Just going to get the width and height of the menu button sprite, just so we don't have to type it several times. This for loop is going to draw our buttons. These are our drawing coordinates. We're going to be using selected option in the step event for this, but for now, every button is just going to be dark grey. But when we are using this option here, selected option, if it equals I, which it will do at some point, then we're going to have the second image, which is the light grey. Otherwise, we're going to have the dark grey version of the button. And depending on the index, that's what we're going to draw here. And we want to draw the text on top of it. So this is the first index. This is the second index. So if selected option equals I, this is going to get drawn. Otherwise, this is going to get drawn. So if we run the game, we can just make sure the buttons are being displayed properly and there's no crashes for anything we've done so far, which there shouldn't be. The amazing intro for the battle, always inspiring. There we go. So we've got four buttons, nice and simple. Let's get on with the next bit now. Okay, so we're going to the step event of OBJ test, and in battle and next actor. So somewhere you'll have a line saying this script here. We're not going to do it here because we only want to show the movement nodes if we choose to move. So just get rid of this line. We don't need it anymore. We've kind of moved it further down. Each actor is going to have a variable to say whether they've moved or not for that turn. And we're going to set it to false when we first set up their turn in next actor. And we're going to set current action to awaiting action and selected option to battle menu.move. This line here, you don't strictly need it. I like to use it to slow down the game. for example, to make sure that the actors are being drawn correctly when they're moving, so to make sure they're being drawn in front of or behind things when they should be, and also to make sure they're facing the right way when moving around. That's what I used it for, really. And then in actor taking turn, this code here, this stuff here, this is what we had in it previously. I decided it was just easier just to comment it out and show you the new code because it needs to be arranged in a certain way. We do use some of this stuff, but rather than kind of go through it bit by bit, it's just easier to show you this. So all this stuff is new, basically, with a bit of recycle code. So if the current action is a waiting action, this means we have yet to choose an option from the menu. Then the first region is going to be pick an action from the menu. If we press up or down, we want selected option to go up or down. So we're going to use our change option script for that. And then still in pick an action, if we press enter, so start node, we're going to use this for the other actions as well, but for movement, we're just going to do movement right for now. So start node is going to be whatever node the actor is currently on. And then we're going to say if selected option equals move, so we're trying to move, and the current actor has not yet moved, then we're going to use our script we had before in next actor. We're also going to use a variable called movement range and put it there. This is so you can have different movement ranges. So you might have a stat for each actor, which can be, between whatever range you want, 4 to 6 to 8, whatever. But for this tutorial, it's always going to be 4. And then within this still, we're going to set current action to select option. And then if we want to end the character's turn, we're just going to press backspace to set battle state to next actor. Pretty simple. Let's run the game. Let's test this now. So we can press up and down and it'll go between them. If I press enter on move, it'll show the possible movement tiles we can go. Pressing up, down, left, right doesn't do anything right now because we haven't coded that yet. We haven't reused it yet. Okay, so now we are going to kind of get back to where we were at the end of the last episode, where we can display a path and move the cursor around. So inside actor taking turn again, this is the code we just did, and here we have an else statement with this stuff inside. So all of this is new, basically. Let's just delete this stuff now because we don't need it. So if current action is not equal to awaiting action, we have chosen an option. Move cursor around, so up, down, left or right, we'll change grid X or grid Y. This was what was in the one of the regions we just deleted. Press enter after already choosing a menu option. So if we press enter and we are on the move option, then this is where we're going to display the, we're going to generate a path basically. Start node is where the character is, end node is where the cursor is, and as long as the end node is in this list of active nodes, then we're going to generate a path. And it says move the unit, but we will have code for moving in a minute. I just wanted to make sure we had this working first. And then we've also got cancel action. So if we have pressed enter and we were about to move or attack and we changed our mind, if we press backspace, then we're going to clear the list of active nodes so it's not still displaying when we go back to the menu, and we're going to set current action back to awaiting action so we can choose another option from the menu. Okay, so now we are back to where we were kind of at the start, at the end of the last video, and we have generated a path of nodes which we can see with like a purple trail, but now we actually want to have a script that will, well, we're going to make the actor move along that path. And the way it's going to work is we're going to have a script that will tell the actor which node to travel to in order. So it's going to travel to them one by one until it reaches the destination. So that's what we are going to get done now. So the first thing we need is a new script, and we're going to call it scr get next path node. It's just going to be used for movement, I'm pretty sure. All we're going to pass to it is the path queue. It's the queue that holds the node to travel to, and then as long as the size of the queue is greater than 0, then get the next node. The next node to travel to is going to be at the end. Otherwise, if the size of the queue is 0, then the next node equals no one, and we're going to return the next node. And we've got a couple of things to add into the actor object. So going to obj actor, create event. Of course, we've got a new enumerator for him. Actor states idle or moving. So we can say, okay, now he's moving, his state is this. And we're going to set his initial state to idle, like that. And then in the step event, we've got a new event, step event, and a new region called moving. So if the state of the actor is moving, we're going to run this code. If the target node is not equal to no one, that means the size of the path queue was greater than 0. Then we're going to check to see if we have arrived at the target node yet. So if either the actor's x or y is not equal to the target node's x or y, that means they have not arrived at their destination. So we're going to say x plus equal sign target node dot x minus x. What this is going to do is, regardless of whether x is less than or greater than target node dot x, we're going to get the sign of that value. So if target node dot x is 5 greater than x, then the sign of that is going to be 1. If target node is 5 less than x, then it's going to be minus 5, and the sign of that is going to be minus 1. So if there's a difference between the x and the target x, it's going to move 1 or minus 1 towards it, and the same with the y, it's going to move 1 or minus 1 towards it. If you want to make it move faster, all you need to do is times this by a number, for example times 2, like that. That's how you'd make it move faster, but for me, I'm happy with a movement speed of 1 pixel per step. So else here, so this means the actor has reached the target node, and we're going to check to see if there's a new node to reach, which is why we're going to use our script again. And then if there's a new node, if this isn't equal to no one, this is going to run again. Basically, this happens until there are no new nodes to walk to. Otherwise, so we finished moving. Maybe I should make this into a region. I think I should actually. I like regions. It's a nice way to organize stuff. Okay, so here we are. We finished moving. We're going to set the actor state back to idle. We're going to set a new grid X and grid Y for the actor. This is important because we're going to use the actor's grid X and grid Y to place it in the actor grid. When we start moving, you'll see later on, when we start moving, we're going to remove the actor's ID from the actor grid when it moves, and when it finishes moving, it's going to go back into a new spot. So set the new grid X, grid Y for the actor, update the actor grid, and then with obj test, for now we're going to say current action is going to be awaiting action. Selected option is going to be battle menu.move, and we're going to clear our list of active nodes just to make sure it's not displaying anything. It looks a bit weird to still display stuff after we finish moving. And that's it for the step event of the actor. So now we're going to go and update the step event of obj test. So back into in battle, then actor taking turn, taking an action, and pressed enter after already choosing a menu option, and then finally move the unit. So inside our check to see if the node that we pressed enter on is within our list. So if it is within the list, so it's somewhere we can move to, we're going to use this with statement. So we're going to say with our current actor, tell them they're moving, tell them they have moved, and also give them their first target node using our new script. And this here is what I was talking about, where we're going to remove the current actor from its current position in the actor grid. What this is for, basically, because for all of the other actors, or for including the current actor when it's not moving, we're using actor grid to draw it. So in the draw event you'll see in a minute, we have a variable called actor, and it gets set to whatever stored inside actor grid. So we want it to be set to no one, so we can draw the current actor ourselves when it's moving, but for everyone else we want it to still draw the actor. So that's everything for the step event of OBJ test for now. And if we go into the draw event and draw cell, battle unit, and underneath, so this is what I was talking about. So we've got a variable called actor. It checks the actor grid. Usually an actor will have its ID stored in here, including the current actor, and that's why it'll say if actor is not equal to no one, draw it. When we move the current actor, actor is going to equal no one because we're setting the current actor's cell as no one, because we don't want to draw it here. We want to draw it ourselves because we want to show the gradual movement, and we can't do it using this code, so we have to use this for it. So we're doing a check to say if the battle state equals the actor taking a turn, and the current actor is not equal to no one, and the current actor state is moving. So basically, is the actor taking their turn, and is the actor trying to move? If so, run this code. So CAXX and CAYY are going to be similar to grid X and grid Y, but they might not be a whole number. So for example, if you see here, CAXX and CAYY could be a number like 1.234 or 1.689, whereas normally we'd be expecting coordinates like 0, 1, 2, 3. But having numbers like this is how we're going to show gradual movement for the character. So we need to check to see if the actor is roughly on a cell or not to draw them properly, because with isometric you can get a problem where you are drawing stuff out of order, whereby an actor might be behind a wall but it's being drawn in front of it and it looks weird and glitchy. So to avoid that, we're going to use a function called ceil, which basically rounds up a number. So if it was 1.234, this would equal 2. If it was 3.45, it would equal 4. So whatever the number is, it gets rounded up. So and that's going to be our grid X and grid Y coordinates. And then we're going to use these two variables. These are going to be our draw X and draw Y. It's the same calculation as this and this. It's just that the variables were changed. So get the grid coordinates, round them up, get our draw coordinates, and draw our character using our script. So if we run the game, we should be able to see this in action now. It's going to look kind of funny though, because we are not changing the facing of the characters. That's something we're going to do next. We're trying to do this in baby steps so that you can follow along and see how it kind of evolves. So let's move this guy here. You can see it kind of slides along. If I come back to someone we've moved before, like this guy, we can see he can just, when it's his turn, he can keep going. Make sure there's no errors or anything. So as long as you are up to there, then you are in the right place. And let's get on to changing their facing, and also having the option to change their facing after they finish moving as well. Okay, so because we're going to show the units facing and allow them to change it, we have a new sprite for that called SPR ISO choose facing. This is what it looks like. We have the sprites in order of E facing the enumerator. So we have west, north, east, south, and whatever facing the player is currently, it's going to determine what index of the sprite we draw. Okay, so next thing is inside the actor step event, we're going to update our new region. So if the actor is not at the target node, we're going to set his facing based on the direction he's moving. So if his X is less than a target, he's going to be moving to the right or east, otherwise it's going to be west. If his Y is greater than the target Y, then he's moving up or north. If the Y is less than the target Y, then he's going to be moving down or south. And because we're changing the actor's facing, our script that draws units is just going to use this to draw the correct sprite. So we don't really need to do much else in terms of facing anyway. And then inside our finished moving region, we're just going to change this from awaiting action to choose facing, because we don't want to go back to the menu straight away. We want to have the option to choose facing first. Then if we go to the step event of OBJ test, in battle, actor taking turn, and so this is our taking an action region, but we've enclosed it in an else statement, and we have this happening first. So if the current action is choose facing, then we're going to do this region. If we press up, change the facing to north, right is east, down is south, left is west. That easy. And so because we're changing the actor's facing, it's going to update the sprite. You'll see that in the draw event in a minute. If we press enter, then what it's going to do is change current action to awaiting action, which was what was originally in the step of the actor object, but we're moving it here now because we want this to happen first. So if we go to the draw event, so draw cell, battle unit. So we're going to comment out this line here where we're drawing the ISO select, because it kind of gets in the way when we're doing the choose facing as well as other things. So this is going to be some new code we've got. So if the actor isn't no one and it is the current actor and the current action is choose facing, we want to draw our new sprite with the current actors facing and the draw X and draw Y values. So let's run the game, see this in action. So two things are going to happen. The actors are going to change facing as they move. And the other thing is we're going to get the option to change their facing after they've finished moving. So let's move this guy around. He should turn as he moves like he does. And we want him to be facing upwards or north at the end. So there we go. Press enter. He's done. Let's go to a different character. Let's move this guy to the other side of him. So now he's facing the wrong way. Let's move him to face south. There we go. So as long as you have something like this or something exactly like this, then you are in the correct spot. Okay, so the last thing I'm going to do today is tease you with a bit of the attack script. So the first thing we want to do is we want to update our SCR display action node, because we're going to be passing it a new variable, and the new variable is going to be min range, this one here, and we've changed range to max range. So because we've inserted this new argument between the rest of them, we just need to make sure that the rest of these arguments have their new order updated. So you're going to have to change all of these to argument 3, 4, 5, 6, this one to 2, and our new one is argument 1. And then further down here where we check the range, so we're only going to add the node to the list if it's greater than or equal to the min range and less than or equal to the max range. So this is going to give us a few new options as well. It means we can't move onto the square we started and waste our turn as well. So that's another good thing. We do need to add this though as well, this line here, because this line would always add the start node to the list, and we might not want that, because if our min range is 1 and the start node is going to be 0, we don't want to add the start node. So we're going to check to make sure the start node is greater than or equal to the min range. Not just the start node, sorry, the current node. We're going to make sure the current node is greater than or equal to min range, and the current node is less than or equal to max range as well. If these two are true, add it to the list. Okay, so last of all, if we go into the end step of OBJ test, actor taking turn, pick an action from the menu, awaiting action and pressed enter. So inside our move option here, we now have a min range of 1 to stop us moving onto the square we started on, which is going to waste our move basically. And we now put min range in the arguments there, like that. You should see it highlighted down the bottom. And then we have a new area here, new block of code. If selected option equals attack, min range, max range is 1. Use our script, our new updated script. If you play around with these values, you can get some interesting results, and that's how the attack system with swords and bows and spears and stuff is going to work. We're just going to have different min and max ranges for the weapons and spells basically. So let's run the game. Let's see this in action. So let's choose attack. So you can see we've got 3 squares we can attack from. Let's go to a different person, choose attack there. So if we have a different min max range, then these squares would be different obviously. You can see he can't target himself. If it was like a healing spell or any kind of spell, we would have a min range of 0, so you can cast heal on yourself and it would affect these squares around you as well. Stuff like that. Yeah, I think we're in a good place to hopefully get most of the rest of this finished for next week. I hope you enjoyed the episode. I will catch you next time. Bye for now.